Okay, hey everybody. I just wanted to come in and talk a little bit more about hog color inheritance. I know the homework is fairly difficult and something that we really didn't get to go over a whole bunch. I uploaded a YouTube video with some examples so you guys can see that there, but here's some narration that we have on this so you can maybe get a little more idea of where to go. So we went through this in class. But there are 4 different loci. You guys should all have the worksheet, the Hog Color Inheritance worksheet. If not, it is on D2L under Content. So you should have that. I think it's just labeled a Hog Color worksheet. But it lists out the 4 different loci that we see on the front page and basically what they are, that kind of thing. And then on the second page, it has all the genotypes for the hogs. But this 4 major loci are what we see. Each have 2 copies. Hopefully you guys understand that. I shouldn't have to go through that. Each parent is going to provide 1 copy. You see the thing here about a blank. We use that in place for a allele that we don't know. There are times that we don't know, and there are times that it doesn't matter if we know or not. Hopefully that'll make sense soon. Okay, so our first one is going to be our extension loci. So this is expressed with an E. So this is going to determine our base color, okay? So we have our big E, our E super P, and the little e. Make sure you guys are understand what the order of dominance is. So our big E is dominant over everything else, okay? So E is going to basically give you a black base, okay? It can be diluted by different loci, but like just to start out, black base, okay? E is epistatic to D and G loci. So what that basically means is if you have at least 1 copy of that big E, either 1 or 2 copies, but at least 1, that those D's and G's do not matter when it determines what the phenotype is. And I explained that some in the examples we did. The E super P is black spotted with a non-white base. So there's going to be some kind of spotting on it. E super P is impacted by all 3 other loci, just like E is, okay? So E is a non-black base color, no spots or anything. Okay, so this next loci is the dilution locus. So just like simple problems that we've done before, our big D is dominant to the little d. These are only going to be able to act on E super P or little e, okay? Just like I talked about in the previous slide. So like it says here, it will not dilute. It can only dilute, those are the non-black base, sorry. And it will not dilute when an E is present in the genotype. So basically, as dilution would imply, right? So when you have 2 large D's, you see that at the bottom, it's going to dilute it completely, right? A heterozygote is going to take what we would usually have a red base, is going to dilute it to sandy, and then homozygous, small d, there's no difference, there's no dilution, okay? So this one's pretty straightforward. If you understand what the word dilute means, you understand that the homozygote dominant here is going to dilute completely. Okay, so our pattern locus, this is the G one. I told you guys before in class that it used to be a K, but I use G so it's easier. So this is going to cause hogs with a black spotted base color to be black with 6 white points. And so the important thing here is to realize that basically the only time this comes into play, first of all, is whenever you have 2 small g's, okay? If you have large G, and a heterozygote, big G, little g, it's not going to do anything, so you don't even want to worry about it. Going one step further, if you have 2 little g's, it can only express the phenotype if you have the presence of E super P, okay? I talked about this in class M2. But basically the E super P gives the phenotype the ability to have like some kind of spotting effect, right? We know that E super P is going to be some kind of non-black base with spots. When you have the homozygosity of the small g, the pattern locus, you are going to basically see those spots localize and it'll be black with 6 white points. So it's really important to remember here that the 2 small g's are only going to do something if you have the 2 small g's, first of all, and then if you have the presence of E super P. It can be E super P little e or E super P, but that's the only time it's going to work, okay? Okay, so the inhibition locus is probably the one with the most advanced, but actually probably is one of the ones that will help guide you a little bit. So the order of dominance here is going to be I, then I super L, and then little I. Make sure you guys are good on the order of dominance. Okay, so first of all, sometimes I like to look like if you have a genotype that has 2 small little i's, you know that the other 3 are going to tell you what the phenotype will be. Okay, so 2 little i's means full expression of base color, so you can almost like move past that. Okay. After that, presence of the I super L allele is going to give a white belt on colored hogs. So basically, if it's I super L, or if it's I super L, little I, either way, it's going to put a belt on them. And a good example of this is if we look at like a Hampshire. So a Hampshire is big E, but has an I super L, and so you see the belt. So basically, when you see a genotype with I super L in it in that first spot, and it also can be in the second as well, you're going to have a white belt on a colored hog. Okay, so moving on, the presence of the I inhibits pigment formation. So homozygotes of the I allele are totally white. This is no matter what the other 3 loci are, you have homozygous large I, they're going to be totally white hogs. Pretty simple. So in the next 3 options here, you're going to see this is dealing with all I heterozygotes. So basically, big I, little I, or big I super L. Okay, so the first one is fairly simple. Whenever you have a heterozygote of the large I and you combine it with the E genotype, so it can be a big E, little e, big E, E super P, but regardless, there's a blank there for a reason, so you guys know it doesn't matter what's sitting there. But when combined with that genotype, it's going to give you a blue butt. Okay, so moving on, we have the heterozygotes. Again, the big I, the large I heterozygotes. There's basically 2 different options. And what you're going to notice here is if you look at your handout too, I actually give you all 4 genotypes for each phenotype option, so it actually helps you a little bit more. But this first one, when you have the E super P blank or little e genotype, and you have the homozygous large D genotype, in combination obviously with the heterozygote large I, this is going to give you hogs that are white. Some may have a few dark skin spots. One thing to remember here, if you're looking at a genotype, right, and you have the E super P and the 2 little e's, we know depending if there's G's in play, we're going to pretend like we're not going to talk about that. Hopefully I won't give you any like that. But what it is that those big D's are pretty much diluting. So we know that's dilution loci. So we know that it's pretty much going to be white anyways. And so along with that large I, it's inhibiting pigment formation more. But we know that there's a chance that E super P in there that some may have a few dark skin spots. So instead of dividing out those even more, we just kind of group them together. And then the last one that we talk about is when you have a heterozygote large I combined with those same E's, but we see a difference there at the D genotype. So it's either a small d, or large D, small d. You're going to have ones that are white. However, many have a red tint and some may have a few dark skin spots. This is pretty self-explanatory too, because of the possibility of spots, right? That's the same thing as the one before. But because the dilution loci isn't fully diluting or might not be diluting at all, there's still probably going to be some type of red tint. So these all come into play, and I think they make sense if you can kind of think about each one individually and combining. It's just really important to understand what overrides or what doesn't. But your worksheet does have those genotypes listed for the heterozygotes of the I allele, and so that also helps you guys going through. I know that not all your options are going to fall under those last 3, but I think it helps a lot in determining what the phenotype will be. Okay, so I shouldn't have to go through all these. I'm not going to. These are on the second page, your breed genotypes, but just so we know what that means. I didn't put a picture of a blue butt up. I kind of talked about it in class, but basically they're going to be like quite a bit of white and then some kind of, spotting-ish on them where they kind of look like blue, just so you guys know. Your Duroc, there's your white ones. Your spots, And then your Poland China and Berkshire, so there's a good example of black with 6 white points. If you notice how the white is pulled to all 6 points. So on your homework, I give you guys some example problems. I do a lot where I do the, a spot, bred to Yorkshire, Yorkshire bred to Berkshire. These are pretty simple and straightforward, right? So it's important to do is it, shows here like to write out the genotypes of both to understand that we get 1 copy from each parent. And this one is pretty straightforward, right? After this, if we look at our handout, we know that this is a heterozygote of that large I, so this specifically falls under, one of those there at the bottom, and will give us, so that's why it's white. However, some may have a few dark skin spots. And this kind of gives you some, this is kind of how I get to that point. And so you guys can read through that, but basically it's telling us has a black spotted base. There's complete dilution. Big G, little g doesn't change the phenotype. And then we know that the heterozygote large I gives us a specific phenotype when combined with those others. So this is just another example. I'll let you guys look through these. These are pretty self-explanatory. I think some of the bigger issues come later on in some of these, so you guys can go through and look at these examples and read through them. If you have any questions on these, let me know. These are probably the ones that are a little more confusing because we do have to divide them up. Basically, you see here, so we did the Punnett square, and we realized that when we deal with each loci separately, which I think is really important, we have to basically go from there. So the first loci, here's the E's. Once we divide them up, we have to make sure if we have to divide another loci that each one is getting divided. So you see the exact same thing here as you see here. And then you multiply down the line, right? So this 3/4 times 3/4 gives you 9/16. 3/4 times 1/4 gives you 3/16. If there's any questions on why these are what color they are, this says black, so these do nothing because it's black. This gives you a belt. This gives full expression of the color, so it is black. Here, there's a non-black base, no spots or anything, so pretty much red, right? So red, and then this gives a belt, red with white belt, and then this is full expression, so they are red. I rolled through those pretty quickly, but I do have that YouTube video I just posted with some examples with ways I did a problem, so that should help quite a bit. This is another one you can kind of look through. I helped some people with some of these problems the other day, and sometimes you might step it, in this case, we split up the E and E super P, these two, and we know that because there's a big E here, these basically don't matter, and that is why, hopefully it didn't confuse you, but that is why I didn't split them just like I did up here. I think that's a good example, and so I hope you guys see that. You could very easily go through and basically divide this off just like I did with these D's, but it won't matter because that big E basically masks what those two loci did. And so if this problem is confusing to anybody, that is why I did it that way. I wasn't trying to confuse you guys, but you can roll through those. That is all that I have for that one right now. So if you guys have any questions, please let me know, but make sure that you watch the YouTube video with examples I gave, and I apologize for being upside down because technology and I obviously did not get along today, and I finally just said screw it and I uploaded it. But anyways, hopefully you guys can get this done. Once again, the due date is this coming Sunday at 11:59 p.m. I will also be posting a quiz. So thank you guys so much.